students, welcome to the science class. In last session we discussed about some of the examples on series resistance and also some of the examples on parallel resistance and also combination of resistance. Remember in this class we are going to study about heating effect of electric current, Joules law and power of a current. Remember, when you are going to see lots time of TV, when you are going to see lots time of TV, your parents are going to be scold you. That is nothing but what they are going to scold you. Just they are going to scold you that see the TV will be heated when you are going to see how much time you are going to see the TV will be heated. So another one thing you observe here is when you are going to watch more time of TV, the TV will be heated somewhat. And also when you are going to see some wires, if you are present in your home, if the work will be heavy, for example in your home some constructions are going there, you are going to cut the tiles, the wire attached to the cutting machines, if you are going to observe after a long period you are going to use the machine, the wire will be also somewhat heated, isn't it? And also sometimes the bulbs are also heated after a long period. If you using the light bulbs are also somewhat heated. So why they are heated, what it is, why the heat will becomes, what that will be studied in this class. That is nothing but heating effect of electric current. What is heating effect of electric current? When in the flow of electric charges in any conductor, when the flow of the current will be happens, there is an obstacles, that is nothing but the resistance of the wire or the resistance of the conductor. Due to that resistance, the flow will be opposed by that resistance, that causes some heating effect. That is nothing but, see here what is heating effect. If an electric circuit is purely resistive, the source of energy continually get dissipated entirely in the form of heat. This is known as heating effect of electric current. Any conductor you may take, it has some resistance. Due to that resistance, the continuous flow of electric current, when the current will be flowed continuously in any conductor, the conductor has some resistance. This resistance uses the some amount of the electric current, and that electric current will be dissipated entirely in the form of heat. That used current, the resistance will oppose the flow of current, and that uses the electric current. That used electric current entirely dissipated in the form of heat. That is known as the heating effect of electric current. Once again you have to remember what is heating effect of electric current. In your examination 3 to 4 marks question will be asked on this topic. What is heating effect of electric current? State the Joules law. They are going to ask what is meant by heating effect of electric current. Give us some examples. Remember, this is one of the important point in your electricity chapter, that is nothing but heating effect of electric current. If an electric circuit is purely resistive, the source of energy continually get dissipated. If the conductor is purely resistive, if you are going to use any material, any electronic materials in your home, if it has a pure resistance, if it has a high resistance, the material will be heated when the electric current will be continuously flows. Or if an electric circuit is purely resistive, the source of energy continually get dissipated in the form of heat. The energy which comes from the electric current will be utilized to convert into its heat. Therefore, the sum of the electronic devices, when you are going to use for a long time, it becomes heated. That is nothing but the heating effect. That is due to the heating effect of electric current. So this is known as the heating effect of electric current. So this heating effect, it is desirable, it is useful in the some of the home appliances like electric iron, electric heater. These are the some of the electric oven. So these are the some of the electric appliances which we are going to use in our home. And also lots of amount of electric appliances are also using in our home. Electric heater, water heater, in that devices this heating effect will be desirable. It is a useful. There is no harmful effects due to that heating in that electric devices, but it is undesirable in some of the appliances like a TV, computers, and your AC, fridges. It is undesirable. Why? Because if that devices will be heated, we know that then we get that an idea that it has high resistance. If it is continuously heated, the electric appliances may be get disposed. Have you got understood? So the heating effect will be desirable in some electrical appliances, it is undesirable in some of the appliances. You have to observe clearly in desirable appliances, some of the resistive material they are going to use, some of the material they are going to use to heat the electric appliances, because the work of that electric appliance is nothing but to give the heat. But in electric fan, it is what is the work of electric fan? It gives a cold air, but it sometimes if you are going to use a long time of electric fan, the fan motor will be get heated, but that heat is not utilized for us. That is not the work of electric fan. So it is undesirable heat produced in some of the electronic appliances. Based on this, Joules make some law on a heating effect. How much heat will be produced in an electric appliance, and how much time if we use the electric appliance, how much heat will be produced, that will be calculated by a Joules law. What is Joules law? What it states? See, Joules law statement, it states that the heat produced in a resistor is directly proportional to square of a current. What it states? It states that the heat produced in a resistor is directly proportional to square of the current, and also it is directly proportional to resistance for a given current, and also it is directly proportional to time for which current flows through the conductor. See, remember the statement of the Joules law. It may be asked in your examination for 2 marks question. State Joules law. What it states? It states that the heat produced in a conductor or in a resistor, it is directly proportional to the square of the current, which amount of current will be flows through the conductor or the resistor. So heat produced by that resistor is directly proportional to the current flowing through the conductor, square of the current flowing through the conductor, and that is nothing but H is directly proportional to the I square. I is the current flowing through the any resistor or a conductor. H represents the heat produced by a resistor. I represents the current. So therefore heat, what it states? It states that heat produced by a resistor is directly proportional to the square of the current. What it means? As the current increases, the heating effect will be increases. I got understood? As the current increases, the heating effect will be increases. That is the first statement of the Joules law. What it states? It states that heat produced in a resistor is directly proportional to the square of the current, and also the heat produced in a resistor, it is also directly proportional to the resistance for a given current. It is also directly proportional to the resistance. If the resistance of the appliances increases, then the heat produced by the electric device is also increases. That is the second statement of the Joules law. What it states? It also directly proportional to the resistance for a given current. If the electric appliance has a high resistance, then it produces high electric heat. It shows high heating effect. I got understood? Another one statement of the Joules law, it is nothing but it also directly proportional to the time for which current flows through the conductor. How much time you will provide electric current through the circuit. It decides how much heat will be produced. If you produce 1 hour, if you produce 2 hours, if you increases the time limit of flowing of electric current through the electric device, when you are going to increase the time period of electric flow through the conductor, so the heating effect will be increases as the time increases. That is nothing but the third statement of the Joules law, that is it also directly proportional to the time for which current flows through the circuit. That is H is directly proportional to small t. Here small t represents time, the time period, that is in which how much time we are going to provide the electric current through the conductor or through the resistor. So listen carefully. Once again I am telling here, what is the statement? Joules law states that the heat produced in a resistor or in a conductor, it is directly proportional to square of current, that is H is directly proportional to I square. I represents electric current, square of the current. Take it as question number 1. And also it is directly proportional to the resistance for a given current, that is heat is directly proportional to the resistance. R represents resistance. Take it as equation number 2. And also it is directly proportional to the time for which current flows through the conductor, that is heat is directly proportional to T. Combining these three equations 1, 2 and 3, what we get? Heat is directly proportional to I square R T, isn't it? Why? Because the first statement states that heat is directly proportional to the square of the current. Second statement states that heat produced in a resistor or a conductor is directly proportional to resistance of the conductor or the current. And third statement tells that heat is directly proportional to the time period which we are going to provide the electric current. By combining these equations 1, 2 and 3, we get another one equation, H is equal to I square RT. This is the expression for the Joules law, which gives heat produced by an electric device. I got understood. If we know the electric current, if we know the resistance of the electronic device, if we know the time period in which how much amount of electric current will be supplied, or how much long time we are going to supply the current to the electric appliances, we are going to easily calculate the heat produced by that electric appliance. That is nothing but H is equal to I square RT. By substituting the values of resistance or time period and also electric current, we get the heat produced by an electronic device, that is heating effect of the electric current, that will be shown, that will be given by one of the scientists called Joules, that is known as the Joules law of heating effect. What it states? It states that the heat produced by a resistor or heat produced in a resistor is directly proportional to the square of the current, and also it is directly proportional to the resistance of the resistor or a conductor, and also it is directly proportional to the time period for which current flows through the conductor. It is nothing but this expression use all three statements, that is equal to H is equal to I square RT. You have to remember this expression in your examination, because on the basis of this expression 2 or 3 marks questions will be asked in a problem section. They may give some problems on this heating effect of electric current. Then what are the practical applications? What are the practical applications of the Joules law? So first one application here, electric bulb. Yes, have you seen the electric bulb, old electric bulb? You have to take one old electric bulb, carefully cut off the glass surface. I got understood. Carefully cut off the glass surface. You may get a thin wire which will be connected in between the two rods in that bulb. That is nothing but the tungsten wire that will be used in the electric bulb. What happens in the electric bulb? What happens when the electric current flows through that circuit, that tungsten conductor? So that tungsten has a high resistance, and also it has a high melting point of 3380 degrees Celsius. It has a high resistance. When it has a high resistance, when the current flows through that conductor, that tungsten wire will be heated. That tungsten wire will be heated. When will be get heated, it transmits some amount of light energy. So when any metal object it will be get heated, it will be emits some light, isn't it? First it will be emits some heat effect, and after onwards it emits some light. So that will be happens in also in the electrical bulb. When the tungsten wire will be get heated, it produces some light rays that will be get by the bulb. That is nothing but the one of the use of heating effect, that is nothing but the electric bulb. In electric bulb, tungsten Wire will be heated due to the electric current and it produces the light rays. And also you have to remember that in the electric bulb they are going to fill noble gases like nitrogen and argon. In the electric bulbs or in the tube lights they are going to use some gases in that bulb. Why? Because that gases increases the life period of that filament. Have you got understood that filament it is nothing but a tungsten wire in a small bulbs, and another filaments are also present in a tube lights. In that tube lights or in the bulbs they are going to use some noble gases. They are nothing but a nitrogen, argon, xenon. See, these are called it as a noble gases. Why they are used that noble gases? Because that noble gases increases the lifespan of that filament, that tungsten. It increases the life filament of that tungsten. And another one question arises in your mind, why they are going to use the tungsten wire in the bulb as a filament? Why? Because it has the high melting point of 3380 degrees Celsius. In your examination they are going to ask a 1 marks question, give reason why the filament called a tungsten is used in the bulb. Why? Because the filament tungsten has the melting point of 3380 degrees Celsius. When any conductor will be heated, if you are considering imagine that you are having one conductor, it has a very low melting point that will be placed in a bulb. When current flows through that filament, the heat will be produced. If the heat will be produced, if the amount of the heat will be increases more than the melting point of that filament, it will be get melted. That's why here in the bulb they are going to use tungsten. Why? Because it has a high melting point of 3380 degrees Celsius. If more amount of electrical energy will be flows through that filament, it will be get heated more, but it's not get melted because it has a very high melting point of 3380 degrees Celsius. You have to remember, in your examination they are going to ask 1 marks question on this basis, give reason why the filament, the tungsten will be used in the bulb, because it has a high resistance and also have a high melting point. Have you got understood? And another one is electric fuse. And also you have to remember, in your home in some electrical appliances like electrical iron and electrical water heater, they are going to use some metals in that to heat the electrical appliances. Which metals they are going to use? You have to remember, they are going to use the metals in such a way that the metals should have more melting point. Why? Because if the electric current increases, the heat produced by the that conductor also increases. If the melting point of that conductor or the filament is low, then it will be get melted. When it will be heated more. Therefore, in the electric heating devices they are going to use metals. They are going to use some conductors or filaments in such a way that the filament should have a high melting point. Another one use of the heating effect of electric current is nothing but electric fuse. Yes, in your home, check some of the boards present in your home. The board contains some switch-like structure. It is not a switch, it is not a plug, but it will be closed. It is nothing but a fuse. And also check your another electronic devices like TV and also stabilizer. One small round cap is present. In that small round cap, a tube is present. A small tube, and that small tube contain a thin wire. A small tube contain a thin wire, that is nothing but the electric fuse. What it is electric fuse? Why they are going to use this electric fuse? This electric fuse is nothing but it is a small device which is we are going to use to protect our electronic devices in the case of overloading. Or also in the case of short circuit. In the case of short circuit or in the case of overloading, if we are going to protect our devices, we should use the fuses. Why? Because what it contains, the fuse. This fuse is this wire is made up of the alloy of tin and copper or tin. It is made up of a tin. Why? Because it has a very low melting point. So why it is used, what, on which mechanism or on which basis it will be works? If the overload, if the current load coming from the conductor increases, it will be connected to our devices. But this fuse, first the first current will be flow through this fuse. The fuse will be connected in your electronic devices in a such a way that if you are imagine this is the fuse, the current coming from the conductor first enters into the fuse, after onwards it moves towards your electronic appliances. What happens here? If the overload happens, if the short circuit happens, then the current coming from the conductor, it is also increases. When it is increases, the fuse contains one tin wire, that is nothing but made up of a tin wire, or it is made up of only of tin and copper. It has a low melting point. It has a low melting point and it has a capacity slightly higher than the electrical appliances. It has the capacity of electric current having the slightly higher than that of the electrical appliances. When the current, the more amount of current will be flow coming from the conductor enters to the fuse, the resistance of this wire increases and the heat will be produced. It has a low melting point. It will be melted and cut down. When the circuit will be cut down, it will be not continuous and the electric current will not flow into the next our electrical appliances, and our electric appliance will become safe. I got understood. In your home also, at the present, at the front door, they are going to make some fuses. Why they are going to make some fuses? Because the current coming from the electrical cable from the outside, it is an alternate current. We are going to say it as a AC, alternate current, because it doesn't has the fixed. The current flow coming from that wire, it is not a fixed quantity. It will be variable. In some cases, the amount coming from that cable will be very high. In that time, what happens? In that case, the one reason that why we are going to use the fuse that at the entrance of our home, why? Because it protects from that high voltage coming from the AC current, that is from the electric cables. So this is another one use of heating effect of electric current, that is nothing but electric fuse. These fuses are used in series combination with our electrical appliances. When the more amount of electric current enters to our electrical appliances, it first enters into our fuse having a small thin wire which is made up of a tin wire, or it is made up of only of tin and copper. It has a low melting point. When more amount of electric current enters into the fuse, the wire will be get heated and will be cut down, and the continuity of the circuit will be discontinued here, and our electric appliances will be safe. Have you got understood? This is the mechanism what we are going to use by using the Joules law, or a heating effect of electric current. Yes, last point of this chapter, it is nothing but the electric power. What is electric power? The rate at which electric energy is consumed or dissipated in an electric circuit. The electric power, it is nothing but the rate at which electric energy is consumed or dissipated in an electric circuit. For example, I am giving here, if you are using an electric bulb for 1 hour, how much energy will be utilized in 1 hour? How much electric energy will be utilized in 1 hour can be calculated by using electric power. That is, electric power P is equal to V into I. What is V here? The potential difference into electric current. But we know that potential difference V is equal to I into R. Substitute the value of P is equal to I into R here. Then we get P is equal to IR into I. That is equal to I into I square, R as it is. P is equal to I square R, but I is equal to V by R. We know that I is equal to V by R. P is equal to, substitute the value of I here, P is equal to V divided by R, it's a square into R. That is equal to, P is equal to V square, that is whole square, we are going to square the V and R. V square divided by R square. Here this R and this square get cancelled. P is equal to V square divided by R. This expression is useful to calculate the power used by any appliances, how much power will be utilized in our home, how much power will be utilized by an appliance in our home. So you have to remember the SI unit of power, it is nothing but watt. SI unit of power is watt. SI unit of power is watt, denoted by the letter W. So remember, when the electric man or electric bill man coming to your home, they were giving you some bill. In that bill they give some consumption rate, that is 3,300 or 3,500. What is the thing? But it is nothing but in a watt. It is the power of that amount of power will be utilized in your home per month. I got understood. Based on this unit, they are going to give, because they have some amount for 1 watt. For if you consider in the today's price of the electric bill, that is for 1 watt they price 3 rupees. 3 rupees per 1 watt, isn't it? Based on this, they are going to give the electric bill. That is by using the electric power. What is electric power? The rate at which electric energy is consumed or dissipated in an electric circuit. That will be calculated by using the formula or the expression P is equal to V square divided by R. Here V represents the potential difference and R represents the resistance. This is all about your electricity chapter. On the basis of heating effect of electricity, that is Joules law, H is equal to R square T, R square T, and also on the basis of the expression P is equal to V square by R, they are going to give 2 or 3 marks problems in your examination. You have to practice some problems on this given in your textbook, and this completes your one of the physics chapter, electricity.